times where you have to use Kirchhoff's rules is when you have more than one battery. You see, this one has one battery. But if I have more than one battery placed in different locations of the circuit, so for example, let's say I have a battery here, then I have another battery, I'll do a simple circuit first, just to illustrate, and then we'll do one more, a little more complex. So let's say this is a 9-volt battery, 10-ohm resistor, and then this is a battery that is, let's say, 6 volts, and let's say this is 8-ohm resistor. So this is a 2-loop circuit, 2 batteries, 2 resistors. Now the problem can no longer ask what is the equivalent resistance, what is the total resistance. Because when you have more than one battery, it doesn't even make sense to say what is the total resistance. Because there's a lot of stuff going on here, right? So the only thing the problem can ask is, what's the current going through each resistor? So for the current going through each resistor here, and it could say, what is the voltage drop across each resistor? So find current, voltage, and power of each resistor. And it could say find the power given by the batteries. Power produced by the batteries. And what should happen? The total power produced by the batteries should equal what? The total power of the given off by the resistors, right? The power that the batteries produce should go to the resistor. So we do it a similar way like we did that circuit. We say, let's say this is the current I1, right? It comes into this junction and splits into I2, and then what's left is I1 minus I2, this here. Okay? So just like we did that one, we say I1 goes this way, splits into I2, and then I1 minus I2 down the middle. And then we do 2 loops, because we have 2 unknowns, 2 loops. We could do this loop, the left loop, so you start here, you go up from the negative of the battery to the positive of the battery, you gain 9 volts, minus 10 I1, you lose voltage, and then you go down this battery. Now over here, there's no resistor. The only thing is the battery. So when you go this way, you're going from the negative of the battery to the positive of the battery. Now, a lot of times what happens is people, when they're going through the battery, they get confused. They look at the direction of the current flow. And they say, wait a minute, if I go across the battery, do I look at the direction of the current flow? Do I lose voltage or what? And here's the answer. When you're going through a battery, you don't look at the direction of the current flow. It doesn't matter. When you're going from the negative of the battery to the positive, you gain voltage. Okay? So don't worry about the resistor. Plus 6 volts. The only time the direction of the current would matter in a battery is if the battery had an internal resistance, right? If the battery itself had a little internal resistance, let's say you were going down 6 volts, and then it had a little R, and then if the current was going down, I1 minus I2, so then if you were to go this way, you would gain 6 volts, but going across the internal resistance, little r, you would lose, because you're going in the same direction as the current. So you would lose I1 minus I2 times little r, whatever the little r was, right? But in these problems, usually we are ignoring the internal resistance of the battery. We're assuming it's negligible. So in that case, if the internal resistance of the battery is negligible, the direction of the current doesn't matter through the battery. Okay, then we're done over here. There's nothing down here, so we're done. Well, actually, if you look at this, we don't even need to know loop 2 to get I1. Okay, that one directly gives us I1. 15 is equal to 10 I1. I1 is equal to 1.5 amps. And then to do this one, the right loop, well, I could either do the total loop or I could do just the right loop, because you just need a second loop. So let me show you how it would work. If I do the right loop, you would, let's say you would start here and then go around this way. So you would go this, you would go positive to negative, you would lose 6 volts, right? And then you would go here with the current, so 8I2, and then that's it, you end up at 0, right? So I2 would equal negative, it's going to be negative current, huh? So negative 6.8, so that's 0.75 amps. What that means is that really the direction of the current is the other way. So what's actually happening is you got I1 is coming this way, 1.5 amps, and 0.75, and then they're going down, and then what's the current in the middle section going to be? I1 minus I2, so it's going to be 1.5 minus, and then I2 is negative 0.75. So the two of them are going to add up, and it's going to give you 2.25. So what's actually going to happen is you're 0.75, 1.5, they add 2.25 goes down, and then splits. 1.5 goes this way, 0.75 goes the other way. So sometimes the problem will ask you, find the direction of the current across each resistor. The direction of the current across the 8 ohm resistor will be to the left. And then across the 10 ohm resistor will be to the right. So that's what it means to get a negative current. It means that you have to reverse the direction of the current that you set up the problem at the beginning, you know. Now, what if we had not done the right loop? What if we had done the whole loop? We should still get the same answer. Okay? So what's going to happen then? Well, we start over here, go up 9 volts, we go across 10 I1, you lose 10 I1, and then here 8, we lose 8 I2. Okay? Remember, at the beginning,